Mode.
Good afternoon and welcome to CAD-1's BIM Energy Analysis Part 2, Revit Energy Analysis, What Tools Are Now Included in My Subscription? My name is Stan Henney and I have on my left here today Mr. Brian Juge.
Hello.
AIA, and this ought to be an interesting webinar today. It's a continuation of our Part 1 from last Thursday, I guess it was.
Yes, I think so.
And that should be up on our YouTube and CAD-1 archives page on our website pretty shortly if it's not already. So,
and for those that missed it, that one we kind of went over using Revit directly within for ComCheck and ResCheck.
Yep.
And a little bit of exploration of what ComCheck and ResCheck really are within the software. Today we'll be focusing on a bit more stuff that's actually included directly within Revit and some other software applications. Before we get to that, though, let's switch on over to the handy slide showing us our interface for those of you who don't know it.
No, that's not quite coming up there.
It works better when I actually show my screen. So
there we go. It does.
Like, wow, that delay's a little off there. So if you can hear us, you know the thing. You've got that raise your hand icon there. All right, we've got a couple people raising their hands. That's great. So at least we're coming in.
And hopefully we don't sound like we're in a tin can, which happens every once in a while. So we're not getting any complaints yet, so that's good.
If you're getting some feedback, sometimes you have your mic on, so you might want to change it over to make sure you're on telephone in there unless you want to talk.
Or mic and speakers.
Or mute yourself.
Yeah. So anyway, you are muted by us anyway, and the way we ask you to do is type questions in. We'll try and get them answered as close to in context as we can. And most of you know the drill here, so let's go ahead and get rolling. This is all I can think of is the band. But anyway, rapid energy modeling, and what we're talking about today is an analytical approach to stimulate building energy usage, quick low-cost techniques. REM develops an estimate of a building's potential energy performance based on geometry, location, design, usage, and occupancy. So it takes into account a lot of the effects. We're going to show you some of that. And then, as you can see, I don't know that I need to necessarily read all this to you, but as you can see, there's some stages. We've got our familiar
little bit.
Error message coming up again today.
Okay.
Moving on to stage in REM, build existing building conditions, establish building location, weather station, and insulation, analyze the model to estimate a building's energy performance, and then this comment from Mr. Juge, rinse and repeat.
Rinse and repeat.
And that basically, a little bit of tongue-in-cheek, but it basically, what we mean is it gives you what we're going to show you gives you the ability to do various iterations of a project. Look at alternatives. See which one either comes out the best for client needs, or maybe you like the best, or whatever the preferences guiding it may be.
And on top of that, it's you're doing these at every stage. You got it at schematic design development, and CDs, and the performance you're going to get back when you're doing schematic design on these projects is going to be greatly changed when you get to the construction document levels and you have that building envelope in there. It's going to change and develop and be a harder number based because you have more information built in the model. So it's both those things, the rinse and repeat on your different ideas and as the project keeps progressing through it. So you're going to continually do this process, this rapid energy modeling.
Well, and we can't stress enough that it's very important to begin the energy modeling and analysis as early as possible in the project, because that's when you have the ability to make the most effective changes as the project progresses, as probably most of you know. The specifications become tighter and tighter, so you really don't have as much flexibility on the project to really have an effect on it.
Here's a couple more terminology terms that we've been going over. One of them is conceptual energy modeling, so CEM instead of REM. And that's just performing it based on masses and stuff. So again, that conceptual design when we're in there. And then the various products you can use with that. That would be Revit and Vasari, and I'll talk a little bit about Vasari and what that is for those of you that aren't aware of it. And then the other one we have is the Green Building Studio, which is it's an Autodesk version of the product out there, but it's being driven by the Department of Energy, the 202 engine standards that are out there. And this takes into account the building materials, utilities, HVAC, the costs and everything that's involved with them. And then we can, this information can be imported into other types of software, and you can see on the screen here, eQuest, Energy Plus, Trace 700, and there's other applications that this information can be taken to. And all this stuff is based on ASHRAE standards in there to kind of fill in the information that needs to be put in the different locations. So there's a couple other things that we'll be looking at.
Now, one of the things you'll notice, and we'll just hit it real lightly here, you'll see a lot of when you're working in Revit and so forth, you'll see a lot of the information, and it'll say source, Autodesk. Well, it really comes from ASHRAE, and for whatever the reason, I don't know if it's some legal thing or whether Autodesk is just doing it because that's what Autodesk does, but it is ASHRAE information and should be able to be trusted even though it says Autodesk.
Yeah, and I think I hit on that last time, but that's one of my big pet peeves, and I know I keep telling Stan that every time. Well, I just wish they'd put that sticker on there or something just telling me it's not Autodesk, it's ASHRAE is where they're getting this from.
Right.
And then this next slide here, we're going to kind of look at where this fits into play. Why look at this rapid energy modeling, and how does it compare with other traditional forms that we've had out there? So we have our what they call carbon calculators and benchmarking, which is some other programs that are out there, all the way up to the traditional energy modeling, so doing the full modeling of the building and other outside programs.
Having an ESCO involved or something like that, perhaps.
And you're really seeing that this is more towards the higher end of usefulness and results, but still cost efficient because, number one, it's pretty much built into the software package that you have. And with subscription, you're able to go in and tap into that. So it's another, again, key thing. What am I paying for with my subscription? Why do I have it?
Right.
So we're able to go in and tap into this area. So that's why we're talking about this. And here, Stan, we have the workflow. So it's just kind of a simple thing on, again, schematic design, so schematic modeling in here. Create your masses, build them up the floor, and then directly in that, within several minutes of creating those masses, you could start putting them in the energy analysis by going into the 360 account. And then within 10, 15 minutes after that, or faster, it depends on your internet connection and how many processes they're doing, you'll actually get results back, and you can start comparing those with your different iterations, your different alternates that you'd have.
And we will go into this. I mean, I know those little slides are a little kind of hard to see, so just we will go into this in a bit here.
Yeah, I'll just open it back up in here. What you'll end up getting out of that is just an energy report from that, giving you various types of information based off of the location you happen to be within the world, well, most of the world anyway, the little tongue-in-cheek there, but the potential cost savings, what you'll be doing for electrical and fuel consumption in there, how the carbon emissions are going to be done, your heating degree day, cooling degree day, your wet bulb temperature, all this stuff that we're used to seeing in different areas. You're going to be able to pull that in from the local weather stations and then compare based on the design that you have. And the more stringent the design is, the better, more accurate you're going to get out of this. One of the newer things they're focusing on is the potential energy savings in here. And we can see that this is a little chart in here. I'll talk a little bit more about that. So we'll bring this up a little bit later. But the building feature analysis, they have, I want to say it's like 12 to 14 different features in here, but they're looking at expanding this in the future. I think as soon as next year is what I'm hearing. So we'll have a lot of other categories inside here that people are requesting. But what we'll see is that this is basically looking at the baseline for what the building is going to be running for, and then we have the potential loss or savings that can be used in this. So we can see here in infiltration is where the biggest losses for this particular building that was done with this design was. And over here we can see that window glazing, we have a lot of loss and a lot of gain. So that would be the area that you want to focus in for your design. So at schematic level you can say, oh, these are the key areas I want to hone in my design on. If I start looking at skylight design, well, I'm not really going to see much potential in that, but the overall window glazing itself, that would be a better area to focus in on, and the window glass rather than something else, or daylighting or something of that nature. Then this is a quick, and we'll look at this green building studio in here. And you can see how it's breaking down the different areas where your floor areas, your total energy costs, electrical costs, all these other areas to look at what the potential is. And this is just another resource in there. Green Building Studio is just an additional resource that you have access to in addition to the other energy report that you're going to get directly from Autodesk 360. So we're going to go in.
Brian, how much are you, because I don't want to ask a lot of kind of redundant questions that you're going to answer. You're going to go into actually showing some of this, at least. I doubt if you'll do an actual upload and get the information back right here, but you know, one of the big things with the Green Building Studio, it is part of your subscription. It is a benefit of your subscription. You can upload the Revit model and the weather station information that you get. Are you going to talk a little bit more about where that weather station information resides so people know where to find it?
Yes, I'm actually going to walk that through in a couple different areas in here. So we're actually going to jump into that right now. There you can see my Green Building Studio. I'm going to minimize that. I'm actually going to start off with, I've got Revit and Vasari, and I'm actually going to start off with Vasari. Vasari is currently it's a free program out there. It's some people before Revit Lite came out called it Revit Lite. It's a mass modeling software. You can go and download it for free. They're on version 3.0 right now. And you can go in and build different masses in here. So here I have a building. Actually took a Revit model. These save as Revit files or .rvt files. But we can go in here and quickly go in and mass our building out. So here I've got a building that we've already been massed out, and I've been running some other stuff in here. But we have levels that we can drop in at different heights in here. Or other data, I'll get to that in a little bit. But just by simply going in and creating a mass, just like we would in any other project, I can go and design that. Come inside, create the forms, and create solid forms just like you would in Revit. So it's nothing different or new in here. It's the same process. It is the exact same thing as Revit, and again saves as a .rvt file.
And you don't necessarily have to use Vasari. I mean, you can do your massing in Revit as well if that's how you prefer to do. It's just Vasari is available. It's kind of geared towards various analysis, not just you know, light gain and sun and so forth, but wind and a number of other tools that can be helpful.
That we're going to take a look at right now. So I'm not going to do a process of actually doing massing. You can look at other webinars and stuff on how to do massing or call us, and we'll talk about doing that. But once you're going in and looking at that, so we'll first go in and look at the first part, which is defining the building location. So inside here, and this is both in Revit and Vasari, I've gone in and I've just located this project in Breckenridge. So I've picked out a site in here, which this particular location is going to be, and we can see in here that I can go in. I've typed in the address, but it's already been spelled out for me. I've got a longitude and latitude indicating where this project resides. Okay, and in here we can see there it is. I can look at it in the map with the terrain, or I can look at it in a satellite view and pick out. And I decided just to pick this little house over here. I've got several projects that I'm doing in Breckenridge, so kind of know the area a little bit. We can import the site image, which is a nice thing to have, so you have that in the raster image inside your project. Makes it nice to show clients in there, and you've got that either in the satellite or the map terrain. So you know, if worse comes to worse, you need the topography for some reason, you can import that topography in. The other thing you'll see inside here, and we can see this a little bit more in Revit, but we've got also these little things over here. These are the local weather stations that are involved in Revit. And you can see right here, it's telling me this one happens to be 0.00 miles away. So that happens to be this one right here. It's telling me what the station ID number is, the year that the data was collected from, I believe, the distance from my project in here. So I can go in and relocate that, or I can start picking up other one-ways. Now, across the globe, on land, in 6 out of your 7 continents, I'm going to start getting specific here, avoiding most of our pole areas. The weather stations are about 8.8 miles away, I was told. So it's about 8 to 9 miles away are where these are at. So you have these weather stations out there collecting data. Now, how this is done? Well, we have our schools and our weather stations, our natural weather stations out there that collect that data, but that's only so many throughout the world. The rest of the data is being extrapolated or taken from flight recorded data through all the different airlines and stuff that are out there. So for years, they've been going in and recording this data and then putting it out there on the internet or putting it out there in some database for us to access. What Autodesk has gone and done is tapped into this database and collected this information and extrapolated that across the globe, giving us all these other what they call virtual weather stations. So they're based on local data, and they're also based on flight recorded data, and I'm sure some other stuff that I'm not 100% aware of. I didn't know if you had any more to add to that, Stan.
No, that pretty much hits it. It's
yeah.
I guess it's indicative of the whole energy industry as a whole, in that there's still a lot of standards and practices and things being worked out as we see it, and you know, the accuracy of these things, I'm sure it's pretty accurate over time, but at the same time, you may want to cross-check it against a nearby land-based system or weather station as well. I mean, there's a lot of things to think about here.
Other things that we can look at, now that I have this location, I'm just going to go over some of this stuff in here. We'll look at the energy simulation. I might look at that more in Revit. But we have some other things. So here we have the windrows, just taking the wind direction from the project. Sorry, I pulled it out, but giving me where my prevailing winds are going to be based on this location, longitude and latitude on the globe. I can then go in and push this onto my project here. Then it'll put that out there, kind of giving me a compass and a little coloration on where that wind direction is, and that seems to be fine throughout the project. And it's going to crank here for a little bit, and if it doesn't work, that's fine. I'll clear it up. We can see it in other. There we go. So we got our prevailing wind, when it's coming from in here that we can see. So again, I go into the windrows. I could pull that up, taking it again from the site location in here. We've got all this other information we can get to, looking at what weather station they're pulling it on from. We also get the solar orientation. Unfortunately, I've already applied that in here, but this will allow me to go in, select what other masses in my project. So I come in here, I select the masses I want to apply that to. I click on it when it's finished, and then it's going to go in and run a report, letting me know I have it set to a higher time. This becomes really quickly, but it allowing me to find out which is the solar faces in here. And here I've got a little chart just indicating the schema A, BTUs, just giving me what's being sun, what's being shaded. We can see on the back side, you know, what least amount of sun is being out there. And this is a pretty simple massing design, but I just want to show that. I can export that out.
And again, if you did this in Revit instead of Visara, you would get virtually the same thing.
Yeah, I think some of this is in Revit, some of it isn't. I know for a fact the wind tunnel has yet to go into Revit, so I'm going to fire that one up. It's going to take a little bit to crank on here. It's pretty energy intensive, so I'm going to let that run in the back. Well, okay, here we go. We've got it in here, and we've got based on site location inside here. And we can see how the wind data is being driven in the project. Now, right now, I don't think I have the compass in here, but based on what's going on, I can set that up to that wind location, and I'll have to import that data in here. But I can see the distance in here. So I've got the different velocity. I can pull up the velocity, make that faster or slower, or I can pull it up in the area here. We've got the position, so I can raise that up and down. and see how the analysis is going to be done. One of the ways I like using this within for my clients is just to show, hey, where is snow going to fall within these projects, and kind of look at how the wind is going to carry this around. Now, having the site and topography is obviously going to make more of an impact, and having all the trees around, having the different surrounding buildings is all going to make a better impact, but we can see this in here. Now, we can start using different types of things inside. I'm going to switch this over to 3D in here, and I'm going to show as flow lines. This tends to be one of my favorite ways to look at it. Pause that real quick. Look at the flow line settings. I'm just going to turn all this stuff on. Come back in and hit the play button. And just see how the wind's going to be changing in here. So this is another one to show we can go in and increase or decrease the threshold, kind of play with all that. But it allows us to go in, and this works sometimes better on bigger projects. So maybe not so much on the small one, but sometimes different eddies and stuff will show. So you have different ways of showing what's going on in here within the project, and just seeing how we can see the wind is going around this car, the wind is going around the trees. Whoa.
If there's a lot of snow, what it's like, what the wind is like when it snows clear over the top of your house.
This is deciding to go wonky on me. All right, so let's put that down. See all that in here and how the wind is being done. So it's a very nice visual feature to have in there. Again, more context that you have in your project, the better off this is going to be for showing us the different analysis and stuff. And we've got a lot more inquiry about this, I should say, right, Stan?
Right. And, again, you can, if you have the terrain model correctly, or if you have surrounding buildings, it gives you a good picture. If let's say you're doing a downtown corridor in a city, and you're putting a new building in, and you need to see how the wind is going to affect that, or this same wind analysis can be applied to things like acoustical analysis and various other dynamic factors like along those lines. So really a pretty versatile tool, and again, it is free right now, and these are things that just help you build better buildings, do better work.
Yeah. Like I mentioned, this version 14 doesn't have the wind analysis yet. Revit 13 does. It's an add-on program. You can go and download that. So if you're in 13, you can pull this in. If not, you're relying on Vasari to provide you for this. I'm hoping this is coming out soon.
By 15.
By 15,
March.
hopefully we have something in there. But if not, I've got this tool in here. That being said, we still have all the other energy analysis stuff that we get into. I'm actually going to close this out, but if anybody had any questions, anything like this, I can always fire back on later in here. So that's what some things we have in Vasari. Again, this is a massing tool, and it's used to greatly.
And for those of you who this is what the Ecotect product that Autodesk bought a few years ago and was selling for a while, and this is what it's kind of evolved into. They took a lot of the better pieces of Ecotect and have turned it into this, and kind of spun some of those off into native Revit and other tools as well. So,
all right. So the next one we have is well, this is Revit. Hopefully everybody's familiar with this, and maybe you've seen this sample project. This is kind of what I was playing with in the other one. Made it a Vasari, or a file that we can use in Vasari. But in here we've got this tab, the Analyze tab in here. We've got all our analysis tools, but we're going to talk about the energy analysis inside here. So the first thing, we can look at it using conceptual masses, which we were looking at in Vasari. We have a conceptual mass in here we can still look at. We also can go in and look at it in the actual building itself. So I've got several different views in here, and I'll pull this in. But depending on your stage of the project and where you're at, you can look at it in a mass or start looking at the building elements itself. So we'll talk a little bit about the massing in this project. So we have the building element mode, or I can go back in the massing mode in here in this view. Now inside we go in and we start setting up our energy standards. And this is where really the heart of getting into this really starts off in the whole project and process. We have the building type in here. And inside the building type, we have, all the different things. This is a single-family home, but museums, hotels, motels, dormitories, all this other stuff. And what happens when doing this? This is going to enact some kind of performance within the building. Okay, so the operating schedule, how many occupants are expected to be in here per the floor area, what kind of heat is generated in there. So a library has a certain amount of storage and people inside involved in the different hours of operations. And even though a library and let's say a fitness center might have the same hours through the day, we're going to have a lot different energy that's being generated in a traditional book library than we would in a workout center, where you're going to have bodies working out as opposed to people at rest. So going in here and choosing the different building type is going to have a great impact in there. I'm not going to pick a parking garage if I have a single-family home or a condominium or something like that. So we've got that involved. The other thing we have in here is the location. Now, again, this is the same location we looked at before. It's just another place to go look for it. We have that same Breckenridge project in here. So if I go in and I zoom in on that, I can see there's the same location. There's that weather station we talked about. We have other weather stations a little bit further away. And if I zoom out, I'm going to start seeing, there's the other ones throughout the region that we see. There's one over near Leadville and a couple off of I-70 near Bard Peak and everything else. So we've got these different areas in here. I can still look at it in the satellite mode or the map mode. However, you will not see you can bring this JPEG image directly in, so that's unfortunate. We also have the weather data, so based off of what we'll see on the weather station, we're going to get the dry bulb and the wet bulb temperature, the mean range to look at in here. We can see how this is being designed, and right now it's in Celsius, so this probably started off in metric, so I have to change it to Fahrenheit, but it's simple enough to do.
Now, one of the things that we're dealing with right now, and I'm going to throw this out there because, even though we're giving the webinar today and we're supposed to be the experts, there's one question that we're trying to solve for a customer is, can we put the information, let's say a weather station isn't necessarily available or the data, they need to put other specific data in, can we put that information into the file independently of just pulling a weather station? We're trying to learn how to do that, and we will learn how to do it in the next little bit. But if any of you have any ideas, send us an email.
Yeah, it used to be we'd take it into another program called Ecotech, and then that could be dumped in the Green Building Studio. However, now that this is all web-based, the workflow isn't there. So we're pursuing that right now. We've got a client who wants to add in some more additional information, and we can get to the data. We just can't import or change the data yet. So
we know it can be done. We're just not sure how it's done nowadays. So
yeah,
let's throw that out.
So
there.
they've thrown something into the works here that's changed how we figure it out by putting it online and making it inaccessible for a little bit.
Yep.
All right. So we have the weather station data. We have the location in there. We can choose a different one if we think it's going to perform better.
Well, and some of the things you might think about there would be that weather station is to the south and a little bit to the east of the building location, and in that particular environment, if your building, maybe the prevailing winds in that area are from the north and the west most of the year, then you might want to pick a weather station that's upstream a little bit and at least average it out, because the winds are going to have a bigger effect coming from the north and the west than as they blow by your place to the south and the east. So just things to think about that you may want to look at as you look at the information coming off these weather stations.
Yeah, I mean, if your closest weather station is on the west side of the Continental Divide and you're on the east side,
yeah,
we all know that there's different weather on one side of the mountain than the other.
Yeah.
And if you don't, take a little trip this winter. You'll find out very quickly that it can change valley to valley out there.
Well, the nice thing is that you can do these iterations, again, like you said, rinse and repeat. You can do these iterations real quickly and easily, so you can at least test theories on this quite quickly without a lot of stress.
Exactly. Getting into some of the other thing we do is set the ground plane. It doesn't exactly know what you know, what level it is. Is a foundation the ground plane? Maybe you have a walkout basement in there. So you got to go in and set that. You got the export category. So if we're using rooms or we're using spaces, we can set that up in there.
Brian, if I might, that's the rooms and spaces is kind of important because you know, or at least for the design industry, because architects are going to tend to work in rooms, MEP people are going to tend to work in spaces, and it's going to define how the Revit model is set up a little bit differently, and perhaps some of the results you'll get. So you do want to take some of that kind of in stride, room spaces, things like that, as you're working with this.
Yes, that's definitely important. And also including if you don't have rooms and spaces, if you're just doing a massing model, we don't necessarily need to worry about that yet. We still can perform the analysis by coming in here, looking at the energy settings, setting that up, enabling the energy model, and then it'll actually divide that into its different zones for you. So in here, what it's done is it's calculated the glazing area, and I'll bring that back up in a second. It's taken that mass in here, and it said, okay, well, how much glazing do we have in here? Oh, I'm going to apply that to it. What was the core offset? So if I had a large office building, where does the core start? Does it start at 5 foot off the exterior wall, 10 feet? In this case, it's 11'9" and some change. But I can go in there and go in and change that. Let's say maybe 5 feet in here. Let's see if we can get that to rerun in here. Looking at that, and now I have an interior core in here. You can see right in here, right, this little volume in there, that little square inside, it's just the first 5 feet that's counted, and then the core exists inside of there. So if you're doing office buildings, this becomes really great potential because you'll have a cooling load on the outside of those walls, but then your heating load is being generated from the core on the inside. So that's what we're looking at in these settings in here.
And again, a lot of times people ask us about, you know, those windows, well, you know, especially in the early stage, and they go, well, my windows aren't going to be anything like this. And well, what you got to understand is the program basically looking at, in this case, 40% glazing. So it's just adding 40% glazing. Now, if you went back into your model and, you know, put windows that were more along the line of what you're going to put in there, you can certainly use those, but if you're in an early stage and you just say, oh, we're probably going to have about 40% windows or 20% windows, it's going to give you something that looks a little like this, which throws people sometimes.
Yeah, and that's important to point out. Likewise, we can come in here and say, well, maybe there's only 20% over the whole building. That model will update, but what I've gone in and done is I've come in here, hit my tab key, whoops, tab, get this area in here. I can actually say, well, this particular, glazing in here, grab the right one. I grab this wall instead. So I'm going to see if I can grab that wall there. This one, instead of using the values by the energy model, I'm going to say this one is a almost full glazing, 80%. So I'm going to come inside and say by surface, and then identify instead of 20%, 80% of this is going to be glazed. And you can see how it's changing that model out. Oops, I hit my little light bulb there. But that's how we can get it to perform better on the model. So even as schematic design, again, I'm not talking about walls or anything like that. I'm going in here and just applying the massing and saying, okay, I've only got 20% on these walls, 80% here, or maybe this is 0. I can go in and change all these out very specifically for the model and then have that performance run, which we'll look at in a little bit. So again, looking at all this in here. Right now this one's set to go through some of the more of these. The working drawings in here, including thermal properties. I'll get to that one in a second. But we've got the core offset, divided the perimeter into different zones. We can see the zones are being divided in here. And then we get the conceptual construction. That's this little edit button in here. And what we can see is that we have different types of construction here. So the mass exterior walls, these are done for lightweight construction, typical cold climate. This model was originally a low insulation, and it was a lightweight construction, which is going to give me different energy performance. So I can go in there and pick all this for the massing of the walls as I'm doing that very preliminary in my project in there, and set that for what other areas I want, including the glazing. So I can go in here and look at the glazing what type of windows we're looking at. Is it a single panel? Is it double panel? Is it low E? Is it triple panel? However you want to make this perform. And obviously on these, 80% glazing on a wall, that's going to make a big difference when we go to run that analysis in there. So we've got that area in here. The target sill height, so I can break that in. That's what it's showing. It's 2'5" and some change. Again, this is a set of a metric. Glazing is shaded. I can go in and turn that on in here, and what you'll see happening is it'll put glazing on there. But the interesting part is, and I guess it's doing to all sides right now, sometimes it'll actually take that off of the different sides depending on what's the sun side in here. But you can see in here, now I've got different shelves. Just by clicking on that, I've got some some shading being done to those windows to give myself shades throughout the year. And that's going to primarily be based on when do you need to start heating the building, when do you start needing to cool the building. So that weather station data you're getting out there is going to determine, well, how big do these solar shades need, these shading devices need to be within our project.
And an interesting kind of anecdotal side note, one of our clients actually did a solar study over the course of a year, how the sun would, the sunlight would hit the building over the course of the year, and then designed, they had this kind of interesting, very organic shaped solar shades based on, during the winter when the sun was lower, the shade was wider in a certain area, and during the summer when the sun was higher, the shade was much narrower on another area of the window. And they were kind of these big kind of S-shaped things, and it was really cool to see. So
yes, there's a lot of huge potential for how you can apply this technology in here, and just great, wonderful things you can get out of it.
Yeah.
Here we have the building operation cost, which relates to the building type. I can go in here and change that, what hours the facility is being run for. You can see some of the defaults that are in here. So the default is set for the single-family residence, but we can go in and change that. We identify our HVAC system. We've got several different types of in here. Hopefully they're going to add a couple more because not everything I think is listed in here. And then our outdoor information, air quality and all that in here. So we go and we set up all these different values inside of here for our mask model, and then we can run our energy analysis for that. And I'll show that in a second how that's done. I'll run the energy analysis in here. But now I want to draw our attention to the actual building. So as the building project gets done and evolves even further, here we have the mask model in here. I'm just going to go in and hide that in that particular view. And just talk about, well, now that the building's developed, what we can look at. Well, one of the things we have in here is the wall type inside, and we can see that in this preview we've got our resistance values. It's not showing up in this wall. It's going to show up in, put it on one of these walls in here. Let me see, grab it, that one.
Brian, while you're
We're going to get some kind of thermal massing that we can look at that, the R value that's involved within here. And this is all based on the materials inside of Revit.
While you're kind of looking at some of that, Juliana, who's one of our regular viewers on many of our webinars, and works pretty extensively with Revit and also the MEP industry, notes that there's a new tool available in labs, and we'll admit it's hard to keep up with all the things that come out. So I don't know if you know this or not, but anyway, it's a tool that conducts daylighting analysis within Revit. She said she doesn't see it on our ribbon, but that doesn't mean we're not aware of it. Maybe you are, maybe you aren't, I'm not sure. She says it's a pretty cool tool that you can use for LEED and should be mentioned in this type of presentation. So thank you for that information. I have the URL here, and I will try to copy that down. You can't just cut and paste off of a webinar, so I'll try and copy that down and post it to everybody.
Yeah, and it is a pretty good one out there. I know we've been looking at that. I think we also mentioned the ELIM tools, although the daylighting analysis is not involved in there yet.
ELIM tools is a good tool.
I've talked with them on that, and they are coming out with that to compete with the Autodesk one.
Yes.
And then you've got lighting analysis that's getting into. But yes, great tools in there, and you're right. They need to be mentioned. It probably should be mentioned in this webinar. but we have those in there. Internally in the program, you have the daylighting in here that that we could run right now if we wanted to kind of look at it in here, and it's it's pretty good. It does great for rendering, but not necessarily for looking at the whole project in its totality as far as actual true daylighting. But it does a good job visually showing you what the analysis is going to be. But that add-on tool is a great tool. So thank you for bringing that up. In there. All right. So looking at that, now we have the walls themselves based on the materials. So inside of Revit, if I go to the Manage tab and I go to Materials in here, this is where all the information is being kept for different stuff in here. So if I go in and start looking at the wood, I'm going to get the appearance and the physical appearance in here, but I also get the thermal properties inside. And this is where we're going to get, well, how is this working? How is this performing in our project? If I want to start really looking at how the material is being done, based on the thickness of the wall and which material I'm going to get different types of performance in this. The part that I mentioned in here is, okay, where is this information being driven from? Well, it's being driven from Autodesk and Revit. We can see in here under information, the source happens to be Autodesk. And this is what Stan and I were talking about before as being my pet peeve in here. I've been told that this is being authored by ASHRAE. Well, then put the source being ASHRAE. Give me a little ASHRAE sticker down here. So if you all can scream about that and just saying, hey, I'd love to use this. I use this now. I'm trying to go in the building department and looking at my performance values for different things in here. I'd love to use this in my project now. And if I come in here, I'm going to do, actually if I do framing, that's the one I want. We can see that we're going to get some different types of framing in here. So I've got my structural framing joists, my wood joists. This is one I'll go in and start looking at that, my bat with fiberglass solid material, just to show, okay, I've got this other type of material in here for typical construction. I think this is the right one, the inside. So I'll typically start using that. And the other thing to do is, like we talked about last time, is do a comparative between this and what you've traditionally done to make sure you're getting the same R values. When you go back to that wall, and make sure you're getting the right performance in there, that we're looking at it, okay, if I build a 2x6 wall, and we have, stucco on the outside or something, our sheething members, 1-inch rigid insulation, and our gyp, that we're going to get the right performance value out of that. Okay, so we use that in here. With that, if we have that on our wall, we can then go back in the analysis tools, go into energy settings, and I can turn this on, include the thermal properties, and that'll include the thermal properties of the walls that are in there, and I can run that analysis. So I'm going to pull up the analysis now of what we're going to get out of this. So I would say run simulation, and I'll show you. I have to be signed into my Autodesk 360 to get this done. This is going to open up an account. It basically says, okay, I can create a new or use the existing. I use the existing in there. I give it a name. I hit continue, and it spits it out to the web. And usually about 3 to 5 minutes later, depending on the complexity of the project on this house, in this particular house, about 3 to 5 minutes later, I can spit that back out. Actually, I'll go in. I'll use a new one. Create a new one, so I'll call this number 3, and let's see how fast that pops up. Hit continue. That'll spit it out to the web and run an analysis for it. Okay, I'm almost done here. There we go. Now it hasn't come back to me yet. It's just out there. Now I can go in and use the results to compare. I can see that I've got a couple out here. This Breckenridge one here. It's still processing. That's the one I just sent out. But I'll look at some other ones that we've got. So I've got the one on the house. I've also got the one based on my preliminary massing in here. And I can go in and look at the two of these. I'm just going to go in and use the compare. And now I'll pull that up full screen, and we can see that there are the two houses. Our initial massing and then our final one in here. We can start looking at it. Okay, we have the same weather station, everything else in here. We shouldn't expect anything else. This is based on 5 people. This is based on 2 people. So we can see how we're looking at the data. We've got all these different figures, and where this is coming from is our local weather station data in here. Our annual carbon emissions, our energy costs, we have all that in here. Now, when I first started looking at this, I'm like, wow, it's interesting, but what do I do with it? Where's this information coming from? Well, I had all these questions that I needed answered. I mean, it's just kind of in our nature as designers to have, okay? Do I trust the data? And after a while, I started determining, you know what, trusting the data exactly, first and foremost, since I didn't have the answers then, I wasn't quite concerned about it. It was more of doing comparative analysis. Okay, so if I had the building position in one area and I ran the analysis, it would give me X number for performance. If I took that same exact program and I twisted it and changed it, here you can see down at the bottom that analysis is ready. So now I have the third one ready to go. So you saw how fast that was. But getting back to the conversation, if I change the building location, if I move that around, I'm going to get it to perform differently. And then I just do a comparison. Okay, in schematic design, if I had your lot here on the site, and then for position A, and I moved it over here to position B, I haven't impacted the cost, really, because it's the same program. All I've done is relocated it and maybe changed the direction a little bit. With that information, based on the same program, I can come down here and say, look, whoops, I didn't mean to get to there. Go back to that compare. Look, I'm performing better just by doing a couple simple changes. So I haven't changed the impact of the project at all, but I can show my clients live and say, hey, look, this is performing better if we just do these sound techniques, these tried and true techniques. I want to make it face more southerly and capture the southern exposure. I'm going to block more of the east-west direction for that exposure into my glazing, and then take into account their views and everything else. So I'm going to provide some more glazing or something in this area and take away glazing in this other area.
Well, and Brian, not to mention just, optimal positioning for, say, the particular owner of this home or maybe a commercial building or whatever it may be. But you also have other factors which sometimes need to come into play, like the position of the building in a group of buildings, say in a downtown campus, or, lots of times what we deal with here in Colorado in the mountains is, ridgeline. You can't have the top of the building popping up over the ridgeline and blocking the view. So you have to kind of say, okay, if we're going to fit these standards, but we're also going to meet energy standards that we have to adhere to, then we have to look at these things. So there's external and internal factors that we can analyze with this.
Exactly. So yeah. And it has to be thought of, all these potential things. And again, it becomes into how much information you put in there. So the more data that you can put in, whether that's physical model data, where the trees are, the buildings in the city, having the proper weather information, or is it, I guess the weather information is the more untangible data, or it's just data itself in the raw format. Are the utilities costs that they're getting these for? These are supposed to be taken from the local utility costs in the area. Are those accurate? We can start looking at those a little bit more and making sure we have that in here. Here we have the potential energy savings, a new feature, but they're looking at, hey, over here we have the greatest amount of savings for doing X, Y, or Z. This is where we're going to have our wall insulation. Seems to be our biggest loss in here, so we want to pay attention to that for the design. Not really control about daylighting controls. It doesn't seem to be that much of a concern in this area. And you can see this is listing a little bit different information over here than over here based on what's been designed. So as this is changing, we can see how this is, or as you change the design, we can see how this stuff changes in here. We got the monthly heating and cooling loads based on the building that's being designed. The simulated electrical in here. We have our annual wind, which we can hopefully isn't changing at the same location, so that'll be in here. And we can see the different months, how that's performing in here. The design data in here, and the annual temperature and stuff, all coming from that local weather station information that's out there. Humidity and things of that nature. So all good things to have. I like using this because sometimes, hey, when do I need to have my heating degree days? When are my cooling loads going to happen? That's what I'm designing for when I'm building my solar shades. When do I need to start introducing solar radiation inside the building so I'm heating it up? Okay, I can be looking in here and immediately get those get that data out there, get that information out there. I'm actually going to grab in this third one, do compare it. Now you can see all three. Here is that third house we just did, and we can see how it's changed a little bit for that project, the process inside. Okay, based on what's going on. Window glazing a lot less because now I put in those shading devices in there, so it's not as big a concern before. So that was good and expected, and hopefully I'm seeing that in there. But I'm going to see some other changes in my performance inside. So here we have monthly peak demand. It's just June and July when I'm going in. So that solar shading is really helping me out in some of my areas in there just by shading that glazing in there. So we can see definitely a potential savings, and you can show that directly to your client. Look, when I do this, I know as a designer, as an architect, that shading my windows in those heating months is great. Here is that physically showing you how this is getting potential for.
Well, and here's what window shades are going to cost you, and here's your potential return on investment of savings, dollar-wise, by doing that.
Yeah,
and things like that.
Exactly. And I should point out we did some other changes in here, so I can't just account it just to that. But that certainly is having some impact in here. All right, so this is the compare data that we're having directly within Autodesk, the energy analysis compare report that you have within the software. The next one I'm going to look at is actually going in here, and I'll look at this one. And we'll open this in the Green Building Studio. Actually, I already have that open. I might have to go in. It's been, there we are. So we have this Green Building Studio. It's actually based off of, well, let's grab the other one. Export that. Whoops, not export it. You can export these out as PDFs, XMLs, DOE2 files, Energy Plus. So you can see there's that process for doing that. That's not what I want to do. I just want to go open that in the Green Building Studio. And there we go. Oh, it's still showing the other one. So I've got, well, I'll show the other one in here. So here inside I have my different projects in here. Oh, it is opening up. Thought it was. Okay, so I've got my different projects in here. Hello.
Hello.
Now it's thinking.
Yes. Aren't we all?
Aren't we all? So pause for dramatic effect. Come on. There we go, Revit. Well, I'll just kind of run through some of these things until it decides to catch up with me. We have a list of all the different projects you can have in there. Oh. Well, that is not on my screen, Stan. That's on your screen. No, probably not. There we go.
Where did we get kicked off? We got kicked off a webinar this morning. Can you folks hear us?
Can you raise your hands if you can still hear us out there?
Our internet crashed this morning. Yeah, they can hear us.
Okay, so we're still on.
For some reason, there we go.
There we go. Now it's finally caught. I don't know what was going on. All right, here we are. My screen looked fine, but nothing else is catching up. So we have our different projects in here. So here I have all my projects. I can go in and look at that Beck house we're looking at. The Breck house, sorry. So I have the different ones in here. I'm going to look at house number 2. We can run those on our different dashboards, and here I can save the different dashboard information and get a profile on our account. Just slow down a second. It's probably going a little too fast for myself. All right, come on.
I think we're just, bear with us, we're just experiencing some very slow internet, which is then creating some additional lag as the screens come up to you folks here. So,
well, and the other fun part is I've got every other analysis piece of software I'm running, which definitely takes a bit of time. Oh, that's never good. You know what? I was going to punt to this one. So I'll bring up that slide that we had before. But inside here, I can start looking at the different types of data. Wow, my machine's just lagging. Huh. One second.
Okay, now you caught up, but
now it's
get a good page.
There we go.
There we well.
Yeah.
We'll hope it'll be good here.
All right. So we have our data. We can look at, there we go, at that house. So here we have the house itself, the single family. We're bringing in the information from the local weather station. It's giving us our annual energy cost that's in there, our electrical costs, kilowatt hours. We've got our fuel consumption that's in there, our floor area. A lot of useful information in here. Annual fuel use and our lifecycle energy, what we're going to see in here. We also have our lead photovoltaic wind analysis that we can get inside for using that in here. Energy use charts, all being pulled pretty much from that same database we're looking at before. Building details and assumptions that we're looking at in here. So what the exterior walls were, what the underground slab was. We can look at all this inside here. So we need to go in and fix any of this or changing that. We can start running, going back in there and sending that all back through. We've got different chart information we can look at in here, how this is being used through our project, and we can see all this is accessible to us, displayed in different ways. So we've got our cost, our energy. So we're using, what that's going to be. All great information in here. The project defaults that we might have. So the info, the building itself, whether it's broken up in spaces or zones, the different surfaces. So we have all our roofs areas in here, the different openings that would be inside, the HVAC that we happen to be using, all that. So we have all the building in here. Now this one doesn't have an actual building usage yet, so not all that's been defined. This one was done by masking. So I'm not going to have the building envelope and information in there. If I wanted to, I can go back to my projects and select that, but I'll save us all the heartache. And the other information, the project details, who the owner is, the address, everything else that we might have in there, how you want to be contacted and stuff, the project members, so you can add more members. And the other nice thing is you can give them different rights in here. So we can make this information available to different people, the owners, the contractors, the rest of the design team, and giving that information and different rights to what's in there. So if you're working with an MEP engineer, mechanical engineer, we can go back and forth and have them update the file. That way it's not all on the shoulders of one of the design professionals to do, that we can share that information out there. We also have the utility information, the utility data sets in there that we can go in and start looking at for our project. The last one getting into is the weather station, where that information is coming from. We've got all the different data out there. We can go in and look at that. And again, it's going to pull up on the globe where that data station is being taken from out there for our project within the globe. Okay, so we can put that in there. Our weather frequency, again, the wind rose data that's out there, the design conditions we're looking for, and then we can download that weather data, save it out as a CSV file, which is going to show us what year they were taking that analysis from, what month, and what every day. And actually, I think it's like every hour they broke it down to, or it's every day.
It was almost broken down to the ridiculous, which is kind of a good thing, because they got a much tighter average, they claim, than had they done it, maybe every week or something.
So this is where we're hoping to break into this and actually go in and import our own additional information, which used to be available through Ecotech when they had it in that mode in there. But hopefully we're going to be able to go in this, verify some of it, tweak it if we need to. A lot of people are starting to own their own weather stations, or different buildings are putting that on there, so they can get that information out there and tying that into the internal weather data that's being collected in the building. How is the HVAC systems being done in the building itself, and all the ways that we're going in and recording that data. So if we do have the exterior temperatures doing something out of the ordinary, the internal building can react to that and light the building when it's cloudy out, or kick on the different furnaces when we need to, based on loads, or transfer the heat throughout the building, based on whatever your HVAC system is doing in the building.
Right. And again, that's why we went back to the spaces and rooms. That's why spaces and rooms get kind of important when you're working on a design at different points. Brian, what else have we got? We're getting close to the witching hour here, so
yeah, that's kind of what I have outlined in here. I don't think I have analysis on that particular room data. I was just going to go in and see if I can pull that up, but for lack of time and this thing crashing on me, I don't want to run that again. But really getting back into, you can start looking at the perimeter walls, looking at the different values and stuff. We can do that. We can go in and save the changes or save a new template, kind of define these a little bit more by filling out more information in here about the openings, the zones, the spaces. We can go in here and start selecting that. So it becomes really nice to go in and start tweaking this a little bit more in here, looking at what the information is going to be, defining those different areas and stuff. So it's got a lot of potential for tweaking this information further once we get the design more involved. So if you've got specifics, you can go into Green Building Studio without having to go back to the model and change that information for you.
Well, folks, we've come to the end of the time here, so we appreciate you joining us today. Hopefully that was gave you a little bit of insight into how to use some of the tools that are available to you and that you are paying for, actually. So you might as well start using them. And appreciate it, and we will talk to you soon. Goodbye now.
Bye.